After setting the cluster and installing Agones alongside with networking plugin, for Kubernetes, we could deploy Launcher, which would interact as a bridge between Kubernetes and users. The launcher is going to be a simple application written in Golang, which would serve the pages through client Go packages, which implement a client set for Kubernetes APIs. I will show the main components of application, but before, let's go through commands which would be used to deploy it. First, I compile the code with go build. This outputs an executable with name main. This executable is used in Dockerfile. With Dockerfile, I create an image which uses several resources, such as web folder with templates and static files to serve pages with Gin. I also were using env file for out0, but let's skip it for now. The certificates are used to serve pages over HTTPS. Then I copy main executable and config with certificates for Kubernetes. This is not the best approach, but for testing it serves well. Let's get back to the long command to decompile it further. So, after building an image on virtual machine, I use the sh command for executing several operations. The characters at the end of the line is used to separate one line into several. It's the same what / does in Linux. Anyway, the first command I use is to say create image as an archive. Then I use ctr to manually import images. This seems like an overhead step, but it's quite useful when you build an image locally, test it, and then transfer as an archive to cloud instance. I also like to wrap around such operations with helpers to print time taken for the commands to execute. Later on, I am executing kubectl apply, which uses prepared image to create a pod. Let's execute the commands. If you are testing it yourself, I highly recommend to use them separately and then combine after you are confident they are working. All these commands will take a few minutes to execute. For now, Docker on my local machine sends the context to the virtual machine and prepares an image. This introduced an additional overhead, but for my purposes it serves well, allowing me to iterate quickly. Once the image is built and moved to containerd, the pod will be created. What I neglected to mention earlier is that our pod.yaml file contains multiple resources within a single YAML file: deployment, service, and an ingress resource. Although they are defined in the same file, each resource, deployment and ingress, is treated as a separate entity by Kubernetes. For larger, more complex applications, it might be beneficial to split these resources into separate files, but for our MVP, this approach serves its purpose. After command execution, I can see an error deployments, services, and ingress not found. This is because they were already removed from Kubernetes, so the command stopped to execute further, skipping kubectl apply. Let's manually apply pod.yaml file to create these resources and check if they are deployed correctly. Container is creating. Now it's running, and we could see that the services also has been deployed. We see that there is a cluster IP which we will use later, and the same is for ingress. They are deployed and they are using the host names. After deployment is complete, we can verify that resources are provisioned correctly. To do this, we can access the Linux machine and execute curl using the cluster IP to test if the application is serving pages. Note that it's essential to use the k parameter to ignore self-signed certificate errors. With the page working as expected, we could further test it by configuring hosts. I've already set up the necessary configuration, which could be seen in hosts file, and if I would run curl on my machine, I will get the same results. That's it for now. Thank you.